6-2 exponential functions. Now we're going to talk about how to graph exponential functions. Let's talk about half folds real quick, okay? When you fold a paper in half, and 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 in half, let's talk about the results of how many folds you would have. 1 fold, 2 folds, 4. But what if I were to fold it again? 3 folds. You're going to get 8 squared. How about 4 squared? 4 folds, 16. 5 folds, 32, and vice versa. Or how about x folds? Notice how it doubles because you're multiplying by 2 each time. Let's talk about exponential functions and how we graph exponential functions. Notice how it's not a straight line. Notice how the answers are going big. They're getting bigger very quickly, okay? So for example, the 2 to the x graph, notice this right there. The bigger the exponent, the bigger, way bigger your answer is. If it's negative, remember it turns into a fraction. If I see this, 2 to the negative 5 equals negative 10, I'm going to be really upset. You're not allowed to do that, period. Okay? Capiche? Capiche. And great, I just broke my pen. There we go. Now I fixed it. Goodness gracious. Okay? Do not show me and you get a negative answer. One thing I forgot to mention, asymptotes. Asymptotes are what makes the graph flat. Oops, let's change this to a different color. There we go. Wait, and nope, come on, change on you, there we go. Right there, it gets flat at the line y equals 0, okay? It gets flat right there at the line y equals 0. So definitely keep that in mind, okay? Whenever it gets flat. And that's for all exponential functions when there's nothing that manipulates it, okay? So let's talk about this, okay? B to the x, or b to the x when b is 1/2. Well, let's talk about this. Let's actually make a table real quick, okay? So for this table here, oh boy, all right. B to the power of, it's acting all funky. Oh, I think I know why. 1 second. All right, let me see if I can take this off. Uh-ohs. Oh, there we go. Let me just take that off, then that on. Maybe it'll restart itself. Come on. Come on. There we go. Yep, I think it works. Fixed it. Voila. How about that? Okay, b to the 1/2. Let's say 1/2 to the power of x. If I make a table for this real quick. -3, -2, -1, 0, 1, 2, and 3. Let's talk about anything to the 0. 1/2 to the 0 is always 1, no matter what, okay? 1/2 to the first is the same number. 1/2 squared is 1/2 times 1/2, it's 1/4. 1/2 to the third is 1/2, 1/2, 1/2, it's 1/8. Remember, if it's negative, it flips. So this now becomes 2, 4, and 8. So this graph actually is gonna do this. Instead of going bottom to top, it's actually gonna go top to bottom. One other thing to know, by the way, this point here, the important point 0, 1, that's going to be crucial, okay? That point is always going to cross there as long as that important point is not manipulated, okay? Remember from the absolute value functions, we had a vertex. That's the important point that we're looking at, okay? By the way, key feature to know that the asymptote, okay, is going to be y equals 0 because it gets flat at the line y equals 0. Okay, let's look at this here. A network administrator uses the function 5 to the power of x to model the number of computers a virus spreads to after x hours. If there's 1,000 computers on the network, about how many hours will it take for the virus to spread? So we need to figure out, when does the answer become 1,000? And notice how it really doesn't. However, in between here and here, it does get to around 1,000. So we can say between 4 and 5 hours is when it gets to 1,000, anywhere between there, okay, essentially. We're not gonna really find the decimal, but I want you guys to kind of get the idea. So let's do this. Let's figure out how it's gonna make 50,000, okay? Let's use good old Desmos to figure this out. Is there Desmos here? There is, how about that, okay? So let's figure out when it's gonna be 50,000, okay? So let's do this. Okay, 5 to the power of x Okay, there's your exponent. And actually what we can do is equals 50,000. Or we can actually just use the table for this. You're gonna click on the circle thing. Okay, let's go back to this. Okay, you're gonna click on settings. Okay, right here, the little crank wheel thing, you're gonna click on table. When you click on table, you can get the next numbers after that when you press enter and enter and enter. And notice how between 6 and 7, between hours or day 6 and day 7 is we're going to infect about 50,000 computers. So we can say between 6 and 7 hours. Okay, between 6 and 7 hours essentially. I'm not having you find the exact number, but just tell me where in between. Where in between. Okay, now when we talk about exponential functions, the important piece here is this value of a. Anytime it's going to be anything to the power of 0, it's always 1, which means the important point now is going to cross at a. So we need to figure out two things. First of all, the beginning number, which is usually when x equals 0, and what we're multiplying by to get to the next number. So notice how from here to here to here to here, it's consistent. When I divide the two previous numbers, I get 3. That is going to be my value of b. There's your function. Boom. That simple. So get this table now. Okay. Here we go. This graph here essentially. So again, in order to do this, you need to have an important point. And that important point comes from the x-intercept, or sorry, the y-intercept. Okay. Then from here, we figure out the next number by dividing the two previous answers. Notice how it's 1/2. Therefore, my b is 1/2 and my a is 1/28. Okay, let's look at this here. Okay, there's your a. Okay, 12 divided by 3, it's 4. 48 divided by 12, that's 4. That's my value of b. Let's make our function. Y equals 3 times 4 to the power of x. Voila, you're done. You're done. Okay, so this next one here. Okay, A is going to be 2187. Okay, let's figure out what B is. Okay, let's divide 729 by 2187. Let's do that real quick. Let's get rid of that table. Okay, 729 divided by 2187. Voila, it's 0.333 or 1/3. It's going to be technical. So essentially, that's a roster. There we go. It's going to be 1/3 when we divide the numbers. So 729 divided by 2187, it reduces to 1/3. That's your value of b. Bing, bang, boom. You got it. You're done. After that, okay? Few more examples. Example 4. Delisha is offered 2 pledge options for donating to a charity. Which option will increase the pledge amount faster over time? Option A, if you're increasing by $100 for the first week arithmetically, or if you're tripling. Looks like after week 5, you get more money compared to week 5 if you just add $25 every week. So it sounds like option B is better because it's exponential. Remember that exponential gets you bigger numbers more quickly. Here we go. Identify each function as linear exponential. F of x equals the number of branches at level x in a tree where each branch extends into 4 branches. So I go from 1, okay, let's do this, okay, 1 to 4, but I'm multiplying by 4. So that means it's going to be 16, then 64, and then vice versa, 256. So that's going to be exponential, okay? This one here, each row increases by 2 boxes. You're adding 2. So this is going to be linear. Okay, you're identifying which one is which. That'll do it here, kids, for this lesson. Definitely read all this. Very important. If you miss reading that, you're not going to get much. You're not going to get much. Okay, have a great day, guys. See you back on the flip side.